Hey guys, okay, let's do the video for 3-12, arc length and sector area. So here's the deal. We're going to go over everything we went over in class. I'm going to say it kind of quickly, but feel free to pause the video if you need to kind of help you get the notes down. So let's take a look at the notes. Okay, let me make sure this all shows up on camera. Most of it's there. All right. So here's the deal. We're going to be dealing with arc length and sector area. The basic premise is that we're taking theta, which is degrees, and converting it to a unit of measure, such as inches or inches squared, feet or feet squared, something like that is what we're doing. There's a lot of information to this, but the math itself is it can be kind of straightforward. For starters, if we're dealing with a arc that's less than half of the circle, this is called the minor arc. If we're dealing with an arc that is more than half the circle, that is the major arc. Same goes for the sectors. Less than half the circle, minor. More than half the circle, major. So I can break that down into a definition and say something like, this should also say sector, so I'll just get rid of that. Minor is theta is less than 180 degrees, and major is theta is greater than 180 degrees. Okay, now, with that being said, 2 pi r, right, in the arc length equation is referring to the circumference. An arc, okay, an arc is part of a circumference. Okay? Just try to scribble that on there. That's part of a circumference. That's what an arc is. So we're using that formula to help find this length. Here I have area of the circle. Okay, pi r squared is the area of the circle. That's kind of what helps us find the area of this sector. In other words, this here, if we're looking at a pizza pie, right, this is the crust of the pie, and this is the sector. Or this is the whole slice. Sorry, this is the whole slice of the pie. And if you're from New York, you know what I'm talking about. We don't call them pizzas, we call them pies. So now, let's take a look at a couple of examples. We're going to look at this one first, even though this is a little bit backwards again. All right, so it says here, find the arc length and the sector area. Well, the arc length formula, let's start with that, is AL equals 2 pi r times theta over 360. Okay, so now I'm going to plug that in. So AL, this is my radius here. Here's theta. Okay, so I have 2 pi 12 times 120 over 360. I'm going to do this in bits and pieces, but you can actually plug this into your fancy calculator all at one time. So now I'm going to have AL equals 24 pi times 120 over 360. So 24 times 120, 24 times 120, and that's 2880. So 2880, or 2,880 pi over 360. All right, notice I'm keeping pi there. Pi, as mentioned, is just a ratio between the diameter of the circle and the circumference. It's not 3.14. 3.14 is a number, and we often simplify pi to 3.14. Pi itself is an irrational number. So to keep the problem accurate and precise, I'm using pi just the same way as we talked about earlier. Instead of converting square root of 2 to a decimal, I just keep it square root of 2. It's more accurate. Now what I'm going to do is I'm going to reduce 2880 over 360, and that gives me 8. So this is 8 pi. And that is my answer. Next, Let's find the sector area. So I'm going to move this over here, and we're going to do the sector area. So sector area equals pi r squared times theta over 360. Okay, this again is theta, and that's the radius. That stuff has not changed. So the sector area equals pi times 12 squared times 120 over 360. All right, and again, just like last time, you could plug this all into your calculator, one of these fancy calculators, all at once using the fraction button, okay? But I'm going to break it down for you piece by piece. So now I'm going to say that the sector area equals 144 pi, 12 squared is 144 times 120 over 360. And I'm going to go 144 times 120, and that gives me quite a large number of 17,280 pi over 360. Notice how pi just seems to kind of be coming along for the ride. All right, that's what he does. We don't really use it in a way. It just attaches to the number and it sits there. And now I'm going to try to simplify this using the fraction button. 17,280 divided by 360, and I get 48. So the sector area here is 48 pi. Now these problems happen to come out into kind of whole numbers. 48 pi isn't exactly a whole number, but it's a nice clean terminating number. If you get a fraction, all you need to do, if you get a fraction, let me put this up there so you can stare at it for a second, or pause. If you get a fraction, all you need to do is just reduce it and leave pi in place. All right, let's take a look at the next example. Okay, let's see if we can see that. All right, good. A 90-degree sector of a circle has an area of 4 pi centimeters squared, and find the radius. So this here, let's use a different color. So this is theta. This is sector area. I knew that because it told me there. And then we're looking, right, I'm going to put some eyeballs there. We're looking for R. Okay, so let's see how that looks. The formula for sector area is SA equals pi r squared times theta over 360. Theta is 90 degrees. There's that. The area is 4 pi. And that's all we have because we're looking for R. Now I'm going to give you guys a hint here. When we have 4 pi, right, as opposed to a decimal, it's actually easier. Because I'm going to tell you right now, as soon as I divide out that pi, those pi's are going to cancel out. And this is going to solve itself. But I'm going to solve this like as if we typically solve for x. R is my x. So I'm going to multiply this by 360 to get that out from under there. I'm going to do my best not to smudge what I'm writing on with my hands. 360 times 4 is 1440. Notice I didn't use pi because pi is just attached. Equals pi r squared times 90. Now, let me rewrite that so it's a little bit clearer. 1440 pi equals pi r squared times 90. Now we're going to divide 90. All right, let's get rid of the 90. Notice I'm doing this in different steps. Now this time I'm not saving. There's ways for me to save time on this by reducing, but I am not saving. I'm not trying to extend this, right? We want to make sure that we divide pi as a separate step because these calculators have a tendency to kind of float pi. And if you divide, let's say if I did 90 pi, right, it might multiply pi in. It's kind of a common thing they do. Now I'm going to divide by pi. Pi divided by pi is 1. So now I have, let's see if you can see this. I'll write it up here. So now I have 16. We went up here. I have 16 equals r squared. And now how do I get rid of a square? I square root it. That gets rid of that square. So now my radius is 4. There it is. Okay, guys. I hope you guys found this video helpful.